Okay, so in the case of the vertical circle, or in the case of the bank curve in a circular track, you're moving in a circular path. If you're moving at velocity v in a circular path, then your acceleration is centripetal toward the center and has magnitude v squared over r. So acceleration v squared over r toward the center. Well, if this is your acceleration, the fact that net force is mass times acceleration tells you that F net is mv squared over r. I mean, if this is your acceleration, then this is your net force. If you know your acceleration and your mass, assuming you know the mass of whatever this thing is, okay, then that's it. End of story. Now, the question of where that F net comes from may be a little more complicated. So let's take a car in the circular track. What are the forces on the car? Well, mg x downward. You have a normal force. Okay. Now, typically, you've got a frictional force, okay? And it'll be a non-zero force. But if you have no friction, then your resultant force is a resultant of mg and your normal force. Yep. Use the vector g. That's more appropriate. And it's kind of like the pendulum. We've got two forces here, and you have a net force. Which is the y component of the normal force, right? Plus the x component of the normal force. Plus the x component of your gravitational force. And your gravitational force has zero x component, right? If your coordinate system is oriented like so. And when you do anything, you want to show the orientation of your coordinate system. Maybe here you draw your x-axis here, your y-axis here. And maybe you just draw a little tilted coordinate system that indicates. But here you're going to want to do these projections and stuff, so it can be useful. Okay? Now there's a little more to it. In this case, if you want to stay in equilibrium, then the y component of your normal force has to equal mg. It has to be equal to opposite to your gravitational force. So mg, where g doesn't have the arrow over it, meaning just the magnitude of this force, have to be that. So you have to take that into consideration. If you've got friction, then that changes things a little bit. And I'll let you worry about that, because I don't want to go into all the different cases. Okay? That's if no friction, so you're down at Bristol Motor Raceway trying to go 100 miles an hour around this curve, and it's a sheet of ice. So you gotta go to avoid sliding down. You don't wanna go too fast to avoid sliding up. And what you want is, again, this. So you're not intending to go toward the center or away from the center, which would correspond to sliding down and sliding up. It's a little complicated, so I'm just giving you kind of an overview. And we can analyze that next time if you want to. After you've seen it, after you work it through, or attempted to work it through if you're not clear on it, we can talk about it. Now, vertical circles confused me when I first saw them. They confused, so I assume they confuse a lot of people, okay? So you got a mass here. Mass M, speed V. So what do you know? If you got M and V and the radius, you know your net force. Okay, so now you can say, here's your car. Here's mg acting downward. What other force is acting in the car? Assume friction isn't a big consideration here, okay? And this could be a Ferris wheel, and the car could be glued to the Ferris wheel, okay? But it could be, you know, some idiot driving a motorcycle around a vertical circle, hopefully a skilled idiot so he stays alive. You don't want to end up loose in there with the motorcycle bouncing around. Hopefully you got a lightweight motorcycle. If that happens, it's still going to be bad. Okay, so you got mg. Is there any other force acting? Is this thing in free fall? Why not? Because that circle is supporting it, and circle is what exerts the normal force, the material in the circle. So you got a normal force, which is perpendicular to the circle, which means the normal force is toward the center. So the normal force is, in that case, in that sense, centripetal, but it's not the centripetal force. Actually, it is. Never mind. It is the centripetal force. So, hopefully, and what I just said is ridiculous. The centripetal force is not the normal force. Centripetal correspond comes from the sum of the normal force and the gravitational force. So, net force is your vector force up here. And since these are vectors, I'll put an arrow over this and an arrow over G. Okay? So you add these as vectors, so this is longer than this one, and they're both vertical if this thing's right at the bottom of the circle. So Again, F net is mv squared over r. So mv squared over r equals the magnitude of F net, right? F net is this plus this, vectors. If you just do it with scalars, it's going to be your normal force minus mg, right? Now let's take the arrows off, and that force is clearly the difference of these. F norm has got to be bigger than mg, because F norm has to support you, but also has to, you know, the difference between just supporting you, what you need here is the normal force, the centripetal force that you need. So you have that, and again, WebAssign does a nice job. It's not WebAssign, it's MyLab. MyLab does a nice job on this, okay? It does a nice job on most things. And, you know, I think the people that designed this ask themselves frequently, what would Dewey do? Okay? It's right along the lines of what he was advocating and what the constructivist perspective advocates. So, I want to look more at the depth of that theory. But this is along the lines of what's been going on in physics education for over 30 years now. Okay. I didn't get the free fall, but basically, you have gravity acting downward and air resistance acting upward. Air resistance might be some multiple of the velocity, because the faster you're going, the more air resistance, right? If you're going fast enough, it's a multiple of the squared velocity. And we'll talk about that next time, but it's pretty easy to understand mathematically. And the chain, we talked a little bit about that. But that's kind of a variety of things that you're looking at. Things that involve centripetal force, things that involve attached masses, or one of them is suspended, and just plain old objects with inclines. There's more to it, but that'll get you started.